Hello, everyone. Welcome to the next episode of the Radio Data Podcast. Today, our expert guest is Henrik Feldt, who works at a company called Causiq. Henrik is the founder of this company, and he is acting as a CEO and CTO. Henrik, welcome to our show.
Thank you so much, Adam. Nice to be here. Thanks for inviting me.
Yes, that's fantastic. I really wanted to invite you to the podcast and talk together. However, as always, let's start with the introduction. So could you please tell us more about yourself?
Of course. Name Henrik Feldt. I'm a Swede, and I think you also have some Swedish background. That's sort of in part how we got to know each other. I have a background in distributed systems and being a consultant for line of business enterprise. I really like to build software that works well for people and to build technical teams capable of creating those software products. I studied in London at Imperial and then later at KTH, and then I continued to work as a consultant. Before then also I worked self-taught as a consultant from the age of 16. And throughout my career, I worked at companies like research laboratories, building HPC systems for convex optimization problems for ion beam cannons for radiation therapy treatment, to blasting systems for calculating how much blasting dough to put into tunnels when you blast into the mountain here in Sweden. I've tried to bootstrap my own company. I've worked at VOI, for example, when they started up as one of the first engineers there, and lots of other things. And that sort of all brought me to this foci point of building Causiq, and that's where I am right now.
Yes, so could you please tell us more about the company that you founded?
Of course. So Causiq is a company that utilizes AI to help marketers understand what are the channels that they advertise in, that they should continue to advertise in, and which should they stop advertising in. Basically, we allow them to do budget optimization, but we don't do it like all the other demand-side platforms out there. We don't do it like the companies that put pixels in all of their ads and then track everyone online. Instead, we track end-to-end using populations. So we track how much you spend each day, how many impressions the ads get each day, and we track how much revenue you get on the other side as a dependent variable. And then we train machine learning to understand patterns and covariances between these two, the variables and the dependent variables. So in a nutshell, in a technical nutshell, that's what we're doing. And the reason that people want to use us is because by just analyzing their system with us, they can see what are the different channels that they should change how much they spend in. Contrary to similar marketing mix models, as it's called, we also do it every day. The classical marketing mix model you do every week. So by doing it every day, you can continuously come back and continuously optimize your marketing spend, which is highly needed when the markets change under your feet. Another upside is that when we track using machine learning and time series analysis, you can start tracking the effect that higher funnel advertising has. Now, what does that mean? Higher funnel means branding activities or getting people to understand that in the future you'll have a sale. Those are top and mid. Whilst low funnel is more like driving traffic to your site. By then, it's preferable that the customer or the lead already has some sort of understanding about what you're selling and about your brand, because then that sort of advertising becomes much more efficient. The problem that advertisers are facing is that Facebook, Meta, Google Ads, TikTok, Snapchat, whatever they might be advertising in, they primarily track the last click. So they track what the customer clicked on or tapped on, and then if purchases are made, which means that they overwhelmingly overqualify low funnel. Instead of saying that, well, you did spend a lot of budget on getting your brand known, but we can't measure it, so we're not going to report it. But in fact, getting your brand known can increase the effectiveness of low funnel marketing by 3x. So because, again, of ML and the way that we constructed the system, we're now able to recognize those patterns as well. And that means that you can provide a much more holistic approach to improving marketing effectiveness.
And can you give us an example how your product can be used by example company? So you can use as an example my company getting data, or maybe
Right.
some other company that you know very well, that it's very comfortable for you to explain, like the value that your product gives to
Sure.
that company, and how different data points are collected, how you use AI and ML.
Yeah, I love that. So maybe I can tell you a story about how we built the product, because I think that when it comes to building startups, those stories can be quite interesting. When we started out, we had a vision that we'd be able to analyze end to end, and we'd constantly highlight what they should act on, and then they act on it, and they earn some amount of money that we've already understood how much. But in order to realize that vision, we had to create a lot of engineering. We had to do data engineering. We had to validate and vet the data. We had to build lots of integrations into different systems, like all the marketing platforms or Google Analytics. We also want to analyze offline, so that we can understand the effectiveness of TV, radio, out of home, podcasts like this, or influencers. And we do that using a UI with drag and drop of CSV files. All of this is then brought together in a dbt data pipeline, and we unify currency, we unify impressions, and all of the different metrics that each platform has into those two single ones, impressions and spend. And that's what we then can have as independent variables in the machine learning models. But when we started building this, we needed to, first of all, we needed to create the model, and we hired the right people to do that. We got the first model out, and we proved that it worked in quotation marks. I'm doing air quotes here. And then we told the customer, hey, we got a model. It tells you your aggregated revenue for a country, and we've done k-fold validation on it, and that looks very, very good. We have an average MAPE of 25%. And this is pretty good, and as far as machine learning marketing mix models go, especially since we're now doing it per day, which is much, much harder than doing it per week, which is the standard. And they were like, but I don't know what MAPE is, and I don't know k-fold validation. How do I know that it works? So we started looking into different ways of making this model that we had more white box. So we looked at, for example, disaggregation in different ways and algorithms to do that. We disaggregated the different channels so we could get attributed revenue. We started looking at the saturation curves and showing those to the user. And then they were like, yeah, this is, okay, now I understand the model, but I still don't understand if it's true, right? So we built the next step, and we built an accuracy graph where you can put any time frame you want as the visual time frame, and it'll tell you exactly how accurate we can predict the revenue during that time period historically. So you look at that every week, for example, to see how well did my former campaigns go the last week, and should I be changing something, or have I forgotten to upload something called dummy variables, like how much discounts do I have, what was the weather, etc., or interest rates. And they said, okay, this is okay. Now we're starting to trust it, because you're visualizing how accurate it is in a way that I can understand it, because I can look at the graphs. This composite uncertainty number didn't give me that much, so the graph is nice. And then they went to the UI, and they looked at what we tell them is the incremental revenue if you had spent 1% more for each day of the last week. Like, what's the margin, the marginal revenue at this time in this country, in this channel? And the question come, what if we double it? And I'm like, but it says 1%. Yeah, but I want to double it to see. And I'm like, okay, but we got to explain that the points, we haven't actually tried those points. We haven't tried doubling it before, but how do we now sort of talk about this and explain it? Well, then we built a scenario modeler. So our app now is quite rich. It's like Photoshop, but for marketers, in a way that they can adjust and they can try out different settings of historical spend and see what would have happened if I had done that, like a counterfactual model. And the UI is real time, and you can see exactly how the machine learning recomputes when you change your previous spend levels. And then I went, okay, we're actually trying to we can get this now. Let's try it. So for one of our customers, we then set up and this is the next level, K-fold validation is good, nice and good, right? But the real proof in the pudding is when you do a controlled experiment. So we did a controlled experiment. We kept one market, one whole country, identical. We didn't change any marketing spend. And then we applied the treatment, the suggested effects, or rather the suggested changes to treatment that our model recommends. Treatment is being spend or impressions, of course. And we managed to cut their cost by 18% in that country with the same revenue. So that's how we sort of got into proper product market fit. At the same time, we've been selling, and now that we can tell them about these actual results, let's say the sales conversation becomes much easier. And from a technological standpoint, it feels so rewarding to be able to use all these technological tools on top of ML and with ML to build something that real people completely unrelated to tech understand.
So, for example, if I start using Causiq in my company, what would be the channels that you would be able to keep track of, and what type of insights, dashboards, and knowledge I would be able to get after like a week or two or a month after I start using your product?
We can track all of them, or we need to track all of them. And that's because our product looks at fluctuations in the independent variables, changes over time. And then it looks at the same fluctuation in your dependent variable, and it does covariance between those two, simply put. Of course, it's more complex, but that's the basics of it. So that means if you then change something that you don't track in the platform, it'll just say that, oh, something changed and it wasn't due to the other channels changing, then maybe I don't know how effective these channels are. And it will reduce their sort of coefficients, their strength, or as it's called in advertising, return on ad spend or return on investment in finance. So if you don't track everything, you're not going to get good results. So that's why the answer is all of it. Secondly, because we work with time series tracking, we need to be able to get as high fidelity data as possible. So precise data, and data is very precise when you have large numbers. So by the law of large numbers, we get more accurate, which means you'd have to spend approximately 50,000 euros a month to get really good results for this in marketing. But the basic idea then, if you do that, then you connect all the digital channels. We run our ELT jobs and then the ETL jobs to transform it into something, or rather the transform jobs. We then apply the machine learning model, and then we expose it, and we say, during this week, you had the return on ad spend of 4.5x the money you spent, which means that you have a cost of something around 20%. Which means cost of sale, the fraction that your marketing spend is over your plain revenue. And then that's something that you can then start to optimize, because you'll get different coefficients for each of those channels. You'll get, you have 4x in one, you have 8x in the other. So then you should move from the 4x channel to the 8x channel in order to spend better. And that way you reach more people that are actually buying, which is sort of implicit because we're optimizing for revenue, or alternatively conversions we also support if you're a SaaS or if you want like a lead generation form. And that way you continuously work with the software. So then going back to the example I mentioned before, where the customer was like, well, what if I 2x it? Well, he should 2x it. And then a week later, the model will have that data point and it will have learned it. And then maybe you will say, oh, it has good ROI still good ROAS. Or the model will have learned that, oh, well, I had never seen this before, so I will now adjust my expectation, my posterior for this channel. And the next time you run the scenario, I'll show that, okay, you shouldn't 2x that channel. And that's why AI becomes a complement to the person rather than something that tells you in a one-off what you should be doing. It works with people who are experts in marketing.
Yeah, it's very, very impressive and very useful, especially in the current microeconomic environments where you need to carefully decide which channels you should use and how much money you should actually invest in a given channel. And also, like, people behavior is changing quite fast. So for instance, what I see is that podcasts are becoming more and more popular. So probably
Yes, exactly.
like exactly this type of audio content would be more and
Mm.
more consumed by
Yeah.
people, and written content such as blog posts or articles can
Mm.
get lower audience, or maybe people will spend less time doing that, because with podcasts you can do many things at the same time. Also, you can do exercising, you can clean
Hmm.
your flat,
Yeah,
or
yeah, exactly.
you can
But it
walk
makes
with
it
your
hard to
dog.
click, right?
Yeah, exactly.
So
and
that's why
and
something's needed.
yeah, so it's really cool. And you also mentioned that you focus on real-time aspect of your solution. You actually told that you are analyzing your data in daily manner, not
Hmm.
weekly, and this is much more harder. So can you explain, like, what are the challenges of doing the analytics and machine learning faster in real time manner, comparing
Mm.
to classic batch way, and whether this investment pays off?
Sure. First of all, it's harder from a machine learning perspective because you have like a seventh of the magnitude, so you have less precision in the number, which means that you have to have larger numbers, and that means we have to be very determined to fetch all of the channels as well. If you miss out a channel and you have pretty big numbers anyway, it's easier to sort of learn the big picture. But it's much harder to recognize patterns, like when you get ad fatigue, or patterns where before Black Friday, people stop buying from you because you're outbidded by the other e-commerce companies. When it comes to the real-time aspect, it's also, again, from a business perspective, useful for people below the CMO level. So digital specialists, for example, or marketing managers are very interested in that feature. What we're doing right now is that we're integrating our offering, which is DBT based right now for the daily, with a real-time platform based on Flink. So as part of measuring end-to-end, we want to enrich the model and make it more accurate by having multiple models in an ensemble, meaning we'll also be doing stream processing to capture sessions and usage patterns, bounce rates, purchase rates, based on different dimensions of that visitor, for example, what region, what campaigns did they click, etc., so that we can create a highly dimensional, you could call it a cube, but in the end, it's about finding what are the segments that you should tweak, and what effect will that have. So that's something we need to get more towards real time, since the structure of the data is real time. The real hard thing to build here is that you want to unify your ETL, sort of bring into a data warehouse style data with the streaming data, so that you can create features for machine learning in a manner that makes them consistent. For example, when you hydrate, or when you spawn a new machine learning training job, you want to have training data up until that timestamp and not afterwards. You don't want to learn from the future, basically, because you might want to do k-fold validation. You want to split your test and training set, for example. So that's something that we are building, and to some extent have built a platform capable of. The next level would be that when we work with customers, we also need to be able to handle backfills, for example. So we need to get data from them, which may be highly inaccurate because they're people and they've never done machine learning before in their companies. So they may, like we've seen from some customers, they're sending us negative discounts rate. It's really hard, and sometimes below zero. Like, how do we treat that? Sometimes above one. Do they then pay the customer to take the product? A bit hard to understand, right? So we sometimes need to be able to roll back backfills of data as well as having timestamped joins with batch and streaming unified. And then bringing all of that into an API that our data scientists can work with. All of this being sort of the platform.
I hear many different opinions about real-time streaming. Usually people say that it's always better to get the dashboards a little bit earlier or get notification a little bit sooner, but still real-time streaming is not that easy to implement well, especially at scale, and handle or corner cases. So it must be a very good use case to invest. So how it is in your case? Is it like a must-have feature or something rather nice to have?
I think what most people miss in that dichotomy is that real-time streaming gets you stream processing, right? Stream processing has the concept of event time. Event time gets you the concept of time-stamped joins and windowing in your SQL. And all of the streaming platforms now have really, really good SQL support, meaning by just hiring regular, in quotation marks again, data scientists who are primarily focusing on building those models, they can use SQL on top of the streaming platforms to build their feature sets. And these timestamps, they also give you the split of test data and training data that you want, and so on. So for us, it's more about correctness than it is about the real-time aspect. But having, of course, like you say, up-to-date dashboards, that's a nice thing to have. And what I think that we're seeing is that many players are approaching this in different manner. You have you got the Flink and you got Spark, you got the real-time and you got the micro-batching in respectively. Then you have Databricks that run on Spark, but they also have built the data lakehouse architecture or the Delta format for shipping data warehouses back and forth. You have Snowflake, that's primarily batch oriented. But Databricks has now built their streaming platform into the data lakehouse thing, which is basically a data warehouse because it unifies the data lake with the data warehouse, and on top of it you get streaming capability, and then you write SQL to transform your data. And I think that when you find a really strong computer science abstraction and you're able to put that computer science abstraction to use to service your customers, that's when you have hit gold. That's when you have something worth digging at. So that's what we're doing. We're utilizing all of these concepts that really smart people have come up with, and we're trying to apply them to our domain and our vertical, which is optimizing marketing spend for online brands.
And can you also share a bit more information about your tech stack? What are the particular technologies that you're using internally?
Sure. So if we start from what we're talking about, streaming and batch, then it's dbt. It's a BigQuery and Postgres. We're using an ELT called Fivetran. And we also have some internal data syncs. They all put it in a data lake, I could say, because it's the load and then transform. And then the transform bit right now is primarily dbt. And then we're using Flink and Flink SQL to fetch views that dbt creates, very whittled down views from all of this data that you can potentially choose from into what we care about. And then that can compute further enriched data, which it can then again save back into either Kafka topics, which we have, or tables, depending on which style of computation that you want. Then we're using the Google Cloud, so we can store data on Google Cloud Store. When it comes to machine learning, we're sometimes snapshotting our models using joblib, which is a way of saving pandas data frames in a serializable format, and that goes onto GCS, Google Cloud Store. But the next level is that when you start working with, again, timestamp joins, then we need a way to store a lot of data in a data lakehouse architecture so that we can do backfills on the streaming data that we're acquiring from customers. And we can join that up with batch data that we have in the database. And then we're implementing a file system on GCS called Hudi, which is again a derivative of this data lake architecture, but open source from, I think, former Uber engineers, might it be. All of this is monitored in different ways. We haven't reached the full ML capability of like real-time monitoring with ML flow, but we're using Prometheus instead, and we're just outputting metrics from the model runs and the model inference. So either the model runs is what we call the training aspect, because we train it constantly as well, every day, or even much more often actually, because they might have backfills and things are changing disjunctly from each other. And then when we do the inference, we're outputting metrics, which we can then visualize in Grafana. We have tracing with loci and tempo, searching enabled by Loki, of course, which also stores on GCS in a compressed format, and then compacting constantly, similar to how Hudi works. So I think from that perspective, we're seeing this trend of utilizing really cheap storage for high-frequency data streams, so that you can do proper replays and proper storage of data that's quite expensive to store on block-level devices that you mount onto your VMs or pods. So that's sort of the streaming bits. Then all of this is running in a service mesh called Istio, and we're using Kubernetes to host it all on Google Cloud. So yeah, I think that's sort of the overview of it.
Yeah.
But of course, there are many details as well.
Yeah, exactly. But it's very impressive, and this stack is very modern. And I also noticed that you use a mix of Google Cloud and open source technologies. Yeah. So probably for each component, you make an educated decision whether to use open source component that you will have to manage to some extent, let's say on top of Kubernetes, or whether you use cloud managed equivalent from let's say Google Cloud technology stack. So so what is your main criteria if you need to decide what type of technology you should use, whether it should be open source or Google Cloud? What do you look at the most?
Well, I think simple and sturdy and something you can rely on is the main criteria. And the second criteria is it a technology which is optimized for this use case? So I mentioned both BigQuery and OLAP, and then Postgres and OLTP. So obviously we have an app as well, and we store data in there. We expose all of that data from Postgres using Hasura, which means we get a really nice GraphQL API without any effort. And then we just generate out the types into React, and you get typed views with zero effort, which means also front-end can work with data directly in the database. It also manages migrations and everything. And it also means that we can now run that environment locally on every developer's laptop. We can we build jobs that anonymizes and cleans data, so that we can have an identical production environment on each laptop. And that's the real boon of open source, the ability to run anywhere. But obviously, a non-functional requirement comes into play, like what's the cost of operating this? And then the next question is there open source for it that is nice to use for some sort of quality variable? And is there something that can operate it for us? One thing that we've done quite extensively is to incorporate something called Kubernetes operators into our platform. So for example, for Postgres, we're using something called the Crunchy data operator, which we've had really good success with. It manages Postgres in 99% of the days. So every 100 days, you have to maybe kill a process, and then it's back up. And we can take that overhead, but we can't take much more, because then we would go with Google Cloud hosted Postgres instead. But we also don't want to run our own data warehouse, because that might become prohibitively expensive. So depending on then our needs, if we're looking at computing on already metric data, we might as well use BigQuery. But if we're looking at storing terabytes of clickstream data, obviously it gets quite expensive if we're going to read that out every time we do a backfill from BigQuery. And that's when Hudi comes into play. Of course, BigQuery also has this time-seeking implementation, but it's a trade-off in this case. And at some point, we also need to look at how do we utilize cloud most effectively? And cloud gives us extremely reliable object storage. So that's something that we can work with. And that's something that sets our company up for success in the long run.
When I listen to you, I have a feeling that launching a company gives you a very, very great journey where you can grow in few directions, like learning a lot of domain knowledge about marketing and also learning about big data technologies, AI and ML at the same time.
You can be both a nerd and a business guy at the same time.
Yeah,
It's
exactly.
amazing.
Yeah, so this brings me to my final question, because we have still a few minutes left. And this is the question about your tips for fresh tech entrepreneurs, because there are many talented data engineers or data scientists who think about building their own product and maybe even creating a company. So what type of advice would you give them based on your own experience and lessons learned after you launched Causiq?
Well, a couple of points in that case. I would say try and learn the ropes of scaling a company at a growth or a scale up first. That way you understand how engineering can work together to achieve much, much greater products than you could yourself. That's really good also when you if you choose to take investment, when you pitch investors, or it's really good when you plan and strategize about what tech to use. I would also recommend that you, if you're just like in quotes again, just a data engineer, then you probably need someone with a UI type skill, someone who can improve the user experience, because in the end you'll be selling to some non-programmer user. So the founding team is very, very important, and looking intently for the right people is, I think, key to success. You want someone who's a doer, someone who's open to change, but also knows when to just pick tools they know off the shelf and get down with it. Someone who can understand the trade-off of let's get something done today. Maybe it's not scalable to 1 billion people, but it's scalable to 1,000 people, and that's what we start with. That trade-off is also very nice to have in a co-founder or yourself. And again, if you've joined a growth company, you'll know approximately where the different limits are, the back of the napkin calculations. The last advice would be that that you find people who can help you on the business side. When you start, so for example, my company got started by me joining a company called Antler, which is a company incubator. I met my co-founder who had a background in marketing and of course still has. So he knows and he speaks the customer's language. So partner up cross-functional so that you get the competencies you need to build your company out. And consider quite deeply, because it's a decision you can't undo later, whether you're a VC type company, someone who takes investment, or if you're a bootstrap type company, and what kind of lifestyle you want to live. Do you want to live a lifestyle where you have a constant stream of income, like a lifestyle company, and you choose your customers and they choose you? You may not grow it to be the biggest in the world, but you can get rich, but not extremely rich. Or do you want to run a VC company where you'll have external stakeholders wanting you to do different things, where you're not as free to run your company, but where you have potentially a very, very big upside because you can hire and you can scale and you can compete much more effectively. So those are some concerns that I would think about if I were to found a company.
This is a fantastic answer. And a follow-up question, would you do something differently if you would start the company again?
We actually had one. It's a really good question, because like looking back, obviously you have more information. I think in the end it comes down to local rationality. Could you have reasoned differently? Because if you could have reasoned differently and you reasoned badly, then it's your decision making around those topics you should be doing differently the next time. But if I were to sort of jump into a time machine with my own company, I think I don't know, because like, again, local rationality. But maybe it would have been better to hire employees to build the first product instead of hiring consultants, which we did. On the other hand, this made it possible for us to go to market really, really quickly, because we could just pick the best consultants and they would want to work with us, as opposed to hiring takes a lot longer. You get longer lead times, but then you get more stability in the company instead. So that's something that I would probably reconsider, but I'm not sure I would change my mind given all the information I had. I think, does that answer your question? Is that a good?
Yeah. So I know that this is a difficult question, because you always make not only you, but everyone always makes a decision based on the information that you had at the time when making the decision. So, for instance, if I knew the lottery numbers today,
yeah,
then
obviously you did differently.
Yeah, exactly. It's very easy then to win the lottery.
Yeah.
Or
yeah.
If you miss the penalty kick in a soccer game, you know that you should kick in the different direction, so the goalkeeper will not save it. So sometimes it's very easy to make retrospective decisions, because you have additional information now, and you didn't have them when you actually made that decision. But it's like always, I like to
you gotta
ask
realize that and be kind to yourself. I mean, you're a human being, and everyone is as good as they can be when they make these decisions. So be kind to yourself and don't blame yourself, but still strive for the stars and push yourself.
Yeah, so I would like to thank you, Henrik, for this conversation and sharing your knowledge and your tips with us. I wish you luck with your company and your product, and I hope that we'll have opportunity to talk in like few years to in the same podcast to hear
I'd like that.
How your company is doing. Yes. So thank you very much.
Thank you, Adam, and take care.